Hi, I'm Vincenzo Coya, and welcome to Stat 545, the video series designed to help you write a clean and modern data analysis. So far in the course, we've only ever been working with a single tibble for doing data analysis. But whether deliberate or not, you'll probably end up with more than one tibble at some point. And how do you put those tibbles together into a single data frame?
For example, take this imaginary guest list for a wedding, containing the RSVP status of everyone invited. Here's another tibble down below of the party email addresses. How can you go about adding the email addresses from this tibble up to this tibble without manually copying them over?
That's one type of task that you might want to do for joining two tibbles. Today we'll see 4 of the more common types of tasks for joining two tibbles together. We'll use the dplyr package for doing this, and the data you can find available on the Stat545 GitHub repository, and I'll add a link to the description where you can find the data. The first type of task is to add columns using a reference tibble. Now, this is the first example that we saw where we're wanting to add an email column to our guest list by referring to a different tibble.
In this case, we're making a new email column in the guest list by looking up the party email in the reference tibble. So the first 4 rows of the guest list, we'll look up the party 1 email, and for the next 2, we'll look up party 2 email, etc. Use the left join function to accomplish this, using the by argument to indicate what variable will be matched between the 2 tibbles. Let's move the email column next to the party column for easier comparison. Notice that some email addresses are missing, specifically for party 5. That's because party 5 can't be found in the reference tibble party_emails. On the flip side, the reference tibble is allowed to have parties that aren't present on the guest list. For example, down here, we have 16 and party 17, which aren't found on the guest list. You can also achieve the same task using the right_join function and swapping the 2 tibbles. These functions are so named because for left join, you're adding data to the left dataset, and for right join, you're adding data to the right dataset.
The left and right joins both add columns to your tibble, and because of this they're called mutating joins, similarly to how the dplyr mutate function adds columns to a tibble. Let's take a look at another type of mutating join. The second type of task is to pool 2 tibbles together. Now with the left and right join, we were adding to a main tibble by referencing a reference tibble. But what if we wanted to just take 2 tibbles and pool them together?
To start, let's suppose that the guest list was created based on your partner's friends and family. Now, you're tasked with adding all of your friends and family. To help, you download a list of your contacts. How can we combine these 2 tibbles together so that your friends and family are in the guest list without making any duplicates? Just use full join to keep all information from both tibbles. This time, we're matching our rows according to the name column because we're comparing people, not parties. At first, the full join tibble looks the same as the left and right join tibbles, but so far there's one thing hinting that this is different. There are 33 rows here, whereas with the left and right joins, we had 30 rows. Scrolling through the tibble shows the reason. You've added people from your contact list that weren't previously on the guest list, and people from the guest list that weren't on the contact list, resulting in one big happy tibble. And what about these NAs? Well, that's because these 3 people have been imported from the contact list, and so we don't have attendance nor meal information about them. And another thing about the full join function is that your mutual friends won't be duplicated.
But what if you wanted to do the opposite task and only add mutual friends to the guest list? In this case, we only want guests that are in common from the original guest list and the contacts list.
Use inner join to achieve this, also matching rows in the two tibbles by the name columns. Now there are only 25 rows. The 5 people on the guest list but were not on the contact list were removed, and the 3 people that were on the contact list but not the guest list were also removed. This also means that we have complete information for everybody.
Unlike the left and right join functions like we saw earlier, which have a main tibble that we add to by referring to a reference tibble, the inner join and the full join functions treat both tibbles equally and pool them together. These are all still mutating joins because they add new columns to your tibbles. But what about a different type of join altogether? The third type of task is to filter your rows according to a reference tibble. So we've already seen that the two tibbles that we work with sometimes have entries in common and sometimes don't. What if we wanted to find out who is in common and what entries are not in common?
Remember that there are 5 people on the guest list that weren't on the list of contacts? There's a way to access these rows directly. To find out who those 5 people are, we can use the anti-join function. As before, we'll match rows using the name column. To do the opposite, that is, filter our guest list down to all guests where we do have an email address in the contact list, just use semi-join. Notice that we're back to the situation where each tibble is treated differently. The guest list goes into the function, and a modified guest list comes out of the function, where the tibble in the second position is only used as a reference.
Because new columns aren't being created here with this type of join, these are called filtering joins because we only reduce the amount of rows based on a reference table. And sure, while it's true that you could do the same thing by doing a left or right join or maybe a full join and then filtering that resulting tibble, this approach is just more direct and simpler. The fourth type of task is to bind two tibbles together. And this is literally just taking two tibbles and smashing them together either by columns or by rows. And there's probably no need to do this.
Here's the guest list again. What if we wanted to add another person to the guest list? You could bind the rows of these two tibbles together using bind_rows. But you might as well be more deliberate and use full join.
In addition to the bind rows function, there's also a bind_calls function for binding columns. And this is especially error prone because you'd have to make sure that both tibbles that you're binding the columns together by, you have to make sure that the rows all match up. Instead, if your task is to actually just make new columns, why not just use the dplyr mutate function or one of the mutating joins that we saw earlier? Well, that pretty much covers joining two tibbles with dplyr. To summarize, starting with mutating joins, first, add a column to a tibble by referring to a reference tibble, and second, join two tibbles together. Moving on to filtering joins, we have task 3, which is filter a main tibble by referring to a reference tibble. And lastly, task 4 is to bind rows and columns with care. I hope you enjoyed today's episode. As always, join us next class where we discuss file input and output. Don't forget to subscribe to this channel so that you can stay up to date with more data analysis goodies.